Hi everybody, in today's lecture we are going to solve the examples related to trigonometric equations. Okay, in that first example is solve sine 2x minus sine 4x plus sine 6x is equal to 0. Okay, so here we write the example as we take positive terms of sine. So here sine, it can be written as sine of 6x plus sine of 2x minus sine of 4x is equal to 0. Now, using the formula sine x plus sine y is equal to twice sine of x plus y upon 2 into cos of x minus y upon 2. Now, here x is a 6x and y is twice y, so it can be written as twice sine of 6x plus 2x upon 2 into cos of 6x minus 2x upon 2, and this term as it is minus sine 4x is equal to 0. So it will gives us twice sine of 6 plus 2 is 8x divided by 2, which will be 4x, into cos of 6x minus 2x is 4x, 4 divided by 2 is twice x, minus sine of 4x is equal to 0. Now here sine 4x can be taken as common term. So sine 4x into bracket, it will remain twice cos 2x minus 1 equal to 0. So here it can be written as sine 4x equal to 0 or twice cos 2x minus 1 equal to 0, which means that is cos 2x is equal to 1/2. Now here sine 4x is equal to 0, which means that 4x, this term will be equal to n pi. Sine 4x is equal to 0, which means 4x is equal to n pi. Or here cos 2x is equal to 1/2. It also written as cos 2x is equal to cos of pi by 3. Okay, because cos pi by 3 is 1/2. So here it can be written as twice x is equal to twice n pi plus or minus pi by 3. Okay, so here we have used formulas sin x is equal to 0, then x is equal to n pi for n belongs to z. Okay, and here cos of x minus cos of y equal to 0, which implies that x is equal to n pi plus or minus y, where n belongs to z. Okay, so we have used these two formulae. It can be written as cos 2x minus cos pi by 3 equal to 0. So here twice x means here it is twice x and y is pi by 3. Okay, so here it can be written as x is equal to n pi by 4 or x is equal to, here we divide throughout to this term, so it will be 2 divided by 2, which will be n pi plus or minus pi by, here 3 into 2 will be 6, because this is 2 is multiple here, and on right side it will be divisible where n belongs to z. Okay, so which is our required answer. Okay, now consider next example. Solve twice cos square x plus 3 sine x equal to 0. Okay, so here we can write 2 cos square x as, or we consider first given part is 2 cos square x plus 3 sine x equal to 0. Now 2 cos square x can be written as, or cos square x can be written as sine square x plus cos square x is equal to 1. So cos square x can be written as 1 minus sine square x. Okay, so here cos square x can be written as 1 minus sine square x plus 3 sine x equal to 0. Okay, so here you can write it as multiply inside, so 2 minus 2 sine square x plus 3 sine x equal to 0. Okay, so it also written as twice sine square x. We multiplied throughout by minus 2 sine square x minus 3 sine x. Here positive term will become negative. Minus 2 equal to 0. Now, so this is a quadratic equation in sine square x. Okay, you know that ax square plus bx plus c equal to 0 is a quadratic equation. Okay, so we solve by taking factor of this a into c, and its factor should be b. Okay, so in this equation it can be written as here 2 into 2 is minus 2 is minus 4. You have to find the factor of minus 4 such that its calculation will be minus 3. Okay, so here you can take 4 into 1 and we need minus 3, so here we take minus 4 plus 1. So it can be written as twice sine square x. Here minus 4 and 1 are factors, so its coefficient first take minus 4 sine x and plus 1 sine x minus 2 equal to 0. Now here taking common, twice sine x can be taken common from first two term. So twice sine x into bracket, here it remains sine x minus 2, and from second bracket take only one common, so it remains sine x minus 2 equal to 0. So these two bracket will be same, so it can be written as twice sine x plus 1 into sine x minus 2 equal to 0. So which will gives us twice sine x plus 1 equal to 0 or sine x minus 2 equal to 0. So here it can be written as twice sine x plus 1 equal to 0, which means sine x is equal to this plus 1 will be negative and multiple will be divisible. So which will be equal to minus 1/2, or sine x is equal to 2. But sine x is equal to 2 is not possible. Is not possible. Since here write down value of sine x lie between 0 less than equal to sine x less than equal to 1. Okay, because for any value of x it will lies between 0 and 1, so it will not go toward 2. So sine x is equal to is not possible. Now here only remains sine x is equal to minus 1/2. So here sine x is equal to minus 1/2. Therefore sine x is equal to minus 1/2 is equal to sine of, now sine is positive in first second quadrant and it is negative in third quadrant. Okay, so here 1/2 is at angle sine of pi plus, it should be plus, and its value will be, now 1/2 is for sine of pi by 6. Sine pi by 6 is 1/2. So here we have to add pi plus pi by 6. So it will gives us sine of 7 pi by 6. Okay, sine x is equal to 7 pi by 6. That means that is sine, or you can write sine x is equal to sine of 7 pi by 6. That means x is equal to, so here we have studied the theorem sine x minus sine y equal to 0, or sine x is equal to sine y. Sine x is equal to sine y, which means that is sine x minus sine y equal to 0, which gives x is equal to n pi plus minus 1 raised to n y. Okay, so here it is in the form sine x is equal to sine y, so it can be written as 9 pi plus minus 1 raised to n 7 pi upon 6, where n belongs to z. Okay, so which is our required solution. Now consider the next example. If sine x is equal to 3 upon 5, cos y is equal to minus 12 upon 13, where x and y both lies in second quadrant. So find sine of x plus y. Okay, so we know sine of x plus y is equal to, formula is sine x cos y plus cos x sin y. Okay, now here cos square x can be written as 1 minus sin square x, which is equal to 1 minus. Now here given sin x is equal to 3 upon 5 and cos y is equal to minus 12 upon 13. So from sin x you can find the value of cos x. So sin x is equal to 3 upon 5, which is equal to 1 minus 3 upon 5 square. It will be 1 minus 9 upon 25. Okay, which is equal to 1 minus 9 upon 25, which means 25 minus 9 upon 25. So it will be 16 upon 25. Now cos square x is equal to 16 upon 25, which implies that cos x is equal to plus minus 4 upon 5. Okay. Now here given that x and y both lies in second quadrant, and in second quadrant here only sine is positive. Okay, so only sine and its reciprocal is positive, sine and cosec. So cos of here x is equal to plus minus 4 upon 5, which means that we have to take cos x is equal to positive or negative. Here it is negative, so we take minus 4 upon 5. So value of cos x is minus 4 upon 5. Similarly, you also given that cos y is equal to minus 12 upon 13. Here write it down, since x lie in second quadrant. Okay, so cos x is negative. Cos x is negative. Okay, here reason for this step. Now also you know that sin square y can be written as 1 minus cos square y. Okay, we have used the formula sin square theta plus cos square theta is equal to 1. Now cos square y, value of cos y is minus 12 upon 13. So 1 minus of 12 upon 13 bracket square. You have to write negative in bracket and take its square. So 1 minus its square is 144 upon 169. Okay, negative square is positive. So it will be equal to 169 minus 144 divided by 169, which is equal to 169 minus 144 is 25 upon 169. Okay, so sin square y is equal to 25 upon 169, which implies that, or therefore you can write it as, or I write implies, sin y is equal to, taking square root, it will be plus minus 5 upon 13. Also again y lies in second quadrant. Therefore sin y is positive. So value of sin y, you have to take a positive, which is 5 upon 13. Okay, so we have get the value of cos x and sin y also. So using in equation 1, which is our sine of x plus y. So here we use sine of x plus y is equal to, equation 1 gives sine of x plus y. Now cos x, sine x cos y, value of sine x is 3 upon 5. 3 upon 5 into cos y. Cos y is minus 12 upon 13. Minus 12 upon 13 plus cos x. Cos x is minus 4 upon 5 into sin y. Sin y is 5 upon 13. Okay, which is equal to 3 into minus 12 is minus 36. Here 5 into 13 is 65. Middle sign 4 into 5 negative, which will be minus 20. 4 5s are 20 and denominator is 65. So which is equal to, both negative, so denominator will be, here denominator is same, so write 65, and minus 36 minus 20 is minus 56. Okay, so you can write sine of x plus y is equal to minus 56 upon 65. Okay, which is our required solution. Okay, now consider the next example. Prove that, it is for your homework, I will give only hint. So here prove that cos 2x into cos x by 2 minus cos 3x into cos 9x by 2 is equal to sin 5x into sin 5x by 2. Okay, so here you have to take LHS and you have to write 1/2 into multiply 2. So it will be twice cos 2x into cos of x by 2 minus twice cos 3x into cos of 9x by 2. Okay, here I have done an adjustment where I have multiplied 2 to this both term and divided by 2 for both, which is outside a bracket. Now we know that a formula twice cos x cos y is equal to cos of x plus y plus cos of x minus y. Okay, use this formula and solve, you can get a required solution. Okay, so this is your homework. Now consider next example. Find the value of tan pi by 8. Now in solution, let x is equal to pi by 8. Then twice x can be written as pi by 4. Okay, now we know that tan of twice x can be written as twice tan x upon 1 minus tan square x. Okay, you know the formula of tan of x plus y. In that we have to put y is equal to x. You can get this formula. Okay, so tan of twice x is pi by 4. So here tan pi by 4, therefore tan pi by 4 is equal to, now put the value of x is pi by 8, so twice tan pi by 8 upon 1 minus tan square pi by 8. Okay, full stop. Now here it can, tan pi by 4 is 1 is equal to twice tan pi by 8 upon 1 minus tan square pi by 8. Now here let y is equal to tan pi upon 8, then we can write 1 is equal to, it is 1, LHS is 1 is equal to twice y upon 1 minus y square, which means 1 minus y square is equal to twice y. So here it can be written as y square. I shift this on right side, y square is twice y is positive, and here minus y square become positive on right side and positive will become negative, equal to 0, is quadratic equation. Okay, so here roots of this are, therefore you know that roots, formula of root, we cannot factorize here because minus 1 here, and we cannot get a factor which value will be 2. Okay, so we have to use a formula minus b plus or minus square root of b square minus 4ac upon twice a, where here in this a is equal to 1, coefficient of it is ax square plus bx plus c equal to 0. Okay, so here first y square coefficient is a is equal to 1, b is equal to 2 and c is equal to minus 1. So it will give y is equal to, it is y, here it is x is equal to minus b which means minus 2 plus minus square root of b square means 4 minus 4ac, 4 into a into c, which is minus will be plus. Okay, because c is minus, so divided by 2 into a, it's 2 into 1 is 2. Okay, so minus 2 plus minus square root of 8 divided by 2. So here 8 can be written as 4 into 2, root 8 is equal to 4 into 2, which can be written as 2 root 2 because 4 outside root is 2. So it will be minus 2 plus or minus 2 root 2 divided by 2, which is equal to minus 2, 2 into bracket minus 1 plus or minus root 2 divided by 2. So 2 will get cancelled and y is equal to, you will get minus 1 plus or minus root 2. Therefore here as you can say that since pi by 8 lies in first quadrant, therefore tan of pi by 8 is positive. Okay, so we have to take, and value of root 2 is greater than 1. Okay, value of root 2 is greater than 1, so we have to take here positive only. If we take negative minus root 2, y will be negative. So here taking y is equal to minus 1 plus root 2. So and y is equal to tan of pi by 8. So we can write tan pi by 8 is equal to 1 minus 1 plus root 2, which is our required solution. Okay, now consider the next example. Tan x is equal to 3 upon 4 and pi less than x less than 3 pi by 2. Find the value of sin x by 2, cos x by 2 and tan x by 2. Okay, so if you observe this, it is in third quadrant. Okay, here in solution you can write here pi is less than x less than 3 pi by 2. Okay, now we have to find sin x by 2, cos x by 2 and tan x by 2. Okay, so in this first pi x 3 pi by 2, here cos x is negative. Okay, cos x is negative. Okay, so therefore also throughout divided by 2, you have to divide this by 2, so it can be written as pi by 2 less than x by 2 less than 3 pi by 4. Okay, so because we have to find for x by 2, so we have to check the value of x by 2 in which quadrant it is lies. So it observe that it will be lie in a second quadrant. So here sin x is a positive and sin x by 2 is a positive and cos of x by 2 is negative. Okay, it is in second quadrant. Okay, pi by 2 less than x by 2 less than 3 pi by 4. Okay, now sec square x plus 1 sec square x is equal to 1 plus tan square x. Okay, which is equal to 1 plus value of tan is 3 by 4, so 3 by 4 square is equal to 1 plus 9 upon 16, which gives us 16 plus 9 is 25 upon 16. Therefore sec square x is equal to 25 upon 16, which implies that sec x is equal to plus minus 5 upon 16, plus pi upon 4. 16 root is 4. Okay, now you can say that sec plus minus 5 upon 4, sec means 1 upon cos, which implies that 1 upon cos is equal to cos x is equal to plus minus 5 upon 4. Now taking reciprocal on both sides, so it will be cos x is equal to plus minus 4 upon 5. Okay, since it lies in second quadrant, this is in third quadrant, and in which cos x is negative. In third, cos is negative, so here cos will be negative, which implies that cos x is equal to minus 4 upon 5. Okay, so here we get value of cos x. We required value of cos x by 2, sin x by 2. Okay, so here we get cos x is equal to minus 4 upon 5, which is our first value. Okay, next, now we know that cos 2x is equal to 1 minus 2 sin square x. Therefore cos x, if you replace twice x by x, that means x by 2. Okay, so here it will be 1 minus twice sine square of x upon 2. Okay, we have to make angle half. Here x, which is angle, twice x is angle, so we are making angle 1/2. Okay, so it will be 1 minus twice sine square x by 2, or it also written as 2 cos square x by 2 minus 1. Okay, so we use here cos x is equal to, we know that, now we know cos x is equal to 1 minus 2 sine square x upon 2. So value of cos x is, now cos x is minus 4 upon 5 is equal to 1 minus twice sine square x upon 2. Okay, so we shift negative term to the left, which will gives us twice sine square x upon 2, and this negative on right will be positive, minus 4 upon 5 on right will be plus 4 upon 5. So it will be 5 plus 5 into 1, 5 plus 4 is 9 upon 5. Okay, so 2 sine square x by 2 is equal to 9 upon 5, which gives sine square x upon 2 is equal to 9 upon 10. Okay, so taking root, it will be sine of x by 2 taking root, which will gives plus minus 3. Root of 9 is 3 and square root of 10 is root 10. Okay, now as we see that it's x by 2 lies in second quadrant. Okay, and in that sine is positive, so you have to take positives. Sine of x by 2 is equal to 3 upon square root of 10. Into bracket we write, since sine x by 2 or x by 2 is in second quadrant. Okay, so we have take sine x is equal to 3 upon root 10. Now again we have derived a formula for, in terms of cos square x by 2 is cos x is equal to twice cos square of x by 2 plus minus 1. Okay, so 2 cos square x by 2, this minus 1 on right will be plus cos x plus 1. Now we here put value of cos x as 4 upon, which is minus 4 upon 5 plus 1. So 5 ones are 5 minus 4, which is 1 upon 5. So 2 cos square x by 2 is equal to 1 upon 5. So which implies that cos square x by 2 is equal to 1 upon 10. So we get cos of x by 2 taking square root on both sides, which will give 1 upon plus minus 1 upon root 10. As in second quadrant, x by 2 is in second quadrant, cos value will be negative. So therefore cos of x by 2 is equal to minus 1 upon 10. Okay, so now after getting sine and cos, you can find directly tan x by 2. Tan x by 2 is equal to sine x upon 2 divided by cos x upon 2. So which will gives value of sine x by 2 is 3 upon root 10. 3 upon root 10 divided by minus 1 upon root 10. So here denominator of numerator and denominator is same, so it's only remain minus 3. So tan of x by 2 is equal to minus 3. Okay, which is our required solution. Okay, so these are the examples related to trigonometric functions. Okay, so please try to solve examples related to trigonometric functions, because there are many more formulas and you have to check whether the problems, which formula is used in that example. Okay, so when we solve examples more and more, you will get an idea which formula you have to use. Okay, so for today we will stop here. In next lecture we will go through our next part. Okay, thank you.